All right, so we're going to continue talking about rational functions. We have another example here of a rational function. We're going to kind of go through the step procedure of first finding the vertical asymptotes and then horizontal oblique and carry on from there. So when I look at this graph, originally, when I see it, from the moment I see it, I think, oh my goodness, that denominator will factor. And of course, the minute I start the recording, it sounds like an entire crowd of people is going down the hall. Okay, so there's the denominator factored, and once I have the denominator factored, then it's really easy to find the vertical asymptotes. So what are the equations of my two vertical asymptotes? How about, 2 and 2, you're right. Thank you for being ahead of me here. It is 2 and 2. So x equaling negative 2 would cause the first binomial to equal 0, and x equaling positive 2 would cause the second one to equal 0. So if I graph my vertical asymptotes, and we are 100% confident that when I graph this function, it will not cross these vertical asymptotes. Okay, those are the numbers which cause that rational function to be undefined. Then the next thing they ask is, do you have any horizontal asymptotes or oblique? Cannot have both, one or the other. So to do this, we look at the degree of the numerator over the degree of the denominator. Well, the degree of the numerator, it's a degree of 2, and the degree of the denominator is also a degree of 2. So when they have the same degree, then you take the ratio of the numbers of the two leading coefficients. So it's a horizontal asymptote, and it's y equaling 2 over 1, or just y equaling 2. Lots of 2's in this function. Okay, so this is your horizontal asymptote at y equaling 2. Because the degree of the numerator was the same as the degree of the denominator. Then they ask us to find the x-intercepts, which we also are very comfortable now at calling these zeros. We know that x-intercepts occur when the y value is 0. So if I go to my function and I take my function out of function notation, and I now replace the y value with 0, okay, this is a pretty high-ordered equation, but remember the easiest thing to do is to cross multiply. So go ahead and kind of like put the 0 over 1, and when you cross multiply, you get a 0 equaling 2x squared. So then, if you divide both sides by 2, you're going to find that your x value will be 0. So you do have an x-intercept. Your x-intercept occurs at the origin, right here. Okay, now when the x-intercept is the origin, that's going to end up being also the y-intercept, but I'll go ahead and show this. The y-intercept is going to occur when the x value is 0. So going back to the given function, if you replace the x value with 0, you get 0 over 0 minus 4, which is 0. So the x-intercept and the y-intercept are both at the origin. So really at this point, we've done the most important steps of getting ready for the rational, with one exception, and that is, does my function, when I graph it, does it cross over that horizontal asymptote? I don't bother to ask about the vertical asymptotes because it cannot do that. But is it possible that it's going to cross my horizontal asymptote? And algebraically, the way you determine this is you set your function actually equal to your horizontal asymptote. So your function is 2x squared over x squared minus 4, and my horizontal asymptote was y equaling 2. So I just put the 2. Once again, as we've done many times, we're going to cross multiply. So anytime you have a fraction equal to a fraction, we just come in here and cross multiply. So I get 2x squared equaling 2 times x squared minus 4, or 2x squared equaling 2x squared minus 8. Now, you're not used to solving anything that looks quite like this, but you'll note in a lot of these cases, you can subtract off the x squared term and then have a statement 0 equaling negative 8. This is one of those cases that cannot happen. You've lost your variable, so this cannot happen. False statement. So does it cross? No. If it's going to cross, you'll get a number there. You'll get an actual x value, which will be the x value of the point of intersection. So at this point, we've done everything we can do algebraically, and now we want to actually graph it and see what the graph looks like. So here's where you pick up your calculator and you graph it. So I'm going to pause the recording for a second. So when you graph it on the calculator now, and you confirm pretty much everything you have a portion up here that hugs these asymptotes but does not cross them. You have a portion down here that hugs your asymptotes but does not cross them, because algebraically we know it will never cross them. And here we hug the asymptotes but never cross them. So this is a case, out to negative infinity and positive infinity, we know for a fact that that rational function will not cross that horizontal asymptote, or it would have shown in my algebra. Okay, pretty cool stuff. All right, so here's another example, trying to give you a lot of practice because these are kind of strange. Again, I always start, if I see that it can be factored, I go ahead and write the factored version of it because that makes it so much easier to get my asymptotes. And this will factor into an x minus 3 times an x plus 2. Okay, so now we can see pretty quickly what are the equations of my two vertical asymptotes. 3 and negative 2. Very good. Okay, those are your asymptotes. So here's your x equaling negative 2. And here's your x equaling 3. Now in Connect Math, they never actually, I think it's just multiple choice in Connect Math with picking the graph. But be sure you have all these details, because all these details will be on your test. Okay, then we need to know, do I have a horizontal asymptote or do I have an oblique asymptote? By taking a look at the degree of the numerator and the degree of the denominator, I have a degree of 1 over a degree of 2. So if the numerator is less than the denominator, by memorization, it is a horizontal asymptote at y equaling what? 0. Very good. So this is my horizontal asymptote. That is actually the equation of the x-axis. All right, so now we want to come in here, staying with the steps, we want to come in here and look for x-intercepts, which occur when the y value is 0. So my function, this is an actual point on this line, this I'm trying to graph. Okay, so when I graph this, I'm now putting a y value of 0 in. We do a lot of cross multiplying when we're doing this work with these rational functions. So once again, I'm going to put the 0 over 1, and I'm going to cross multiply, which is pretty messy. So I get 0 times the x squared minus x minus 6, which is 0, and 1 times x minus 1. So we do get an x value of 1, so the x-intercept is the point 1, 0 right here. So very obvious, I'm going to cross the horizontal asymptote at that point, right? We're on the horizontal asymptote. Okay, so to find the y-intercept, that's the point where the x value is 0. Okay, so I go back to my function, my given rational, and this should always kind of be relatively easy to put an x value of 0 in. A lot of aircraft in the air today. It sounds like we're outside. Get that to minimize. Okay, so this is going to be 0 minus 1 over 0 squared minus 0 minus 6, which is a 1/6. So I do have a y-intercept. My y-intercept is occurring at the point 0, 1/6. 1/6 is going to be kind of hard to see on this graph, so we're just going to kind of try to get it a little less than a half on the y-axis. Okay, so we kind of already realized this, but the next step is to say, does my f of x cross my horizontal asymptote? And we pretty much already know it does, but we can show it algebraically very quickly by setting these equal to each other. So my f of x is x minus 1 over x squared minus x minus 6. Now we're going to be serenaded by a choir or something. Are y'all hearing that? Oh my gosh. Equaling the horizontal asymptote, which we determined to be y equaling 0. So this is 0. And we've already done this. We know how this works out. When we cross multiply, we get 1 times x minus 1 and 0 times that trinomial, which is 0. And so, yeah, it does. And it does cross at the point 1, 0. Okay? So once again now, in the old days, before we had graphing calculators, this is when we built a table and we just started coming up with all kinds of points. But today we have it a lot easier, and we go to a graphing calculator, put this in, and graph it and see how it kind of fits all around my asymptotes, and then sketch it. Now the graph on the calculator looks like this. It's hugging this asymptote and then it shoots up. It's coming from the high through my y-intercept, through my x-intercept, and dropping down. And then it again is above the x-axis here. So it looks like this. Okay, so that's what your graph looks like. It's a lot cleaner than that, of course, on the calculator. Not freehanding. Okay, but it looks something like this. It did cross the horizontal. Remember, it will never cross the vertical, and at this point it will never cross the horizontal asymptote anywhere else out toward positive infinity and negative infinity. It will not ever cross it again, except for at this one point right here. This is the only place it will ever cross the horizontal asymptote. That's what your algebra does so beautifully for you. Makes you confident. Between it and your calculator, you should feel really confident. Okay. Back when we didn't have calculators, this stuff was not easy. Okay, so now this one, once again, go through the procedure until you're feeling good about all of these. It is already, well, you could factor the numerator, but you don't have to in this case if you wanted to. And I'm going to show you this. This book doesn't show you this, but sometimes when you factor, if you get a binomial in the numerator and another in the denominator and they cancel, and this book doesn't go into it, but if they do, you actually have a hole in the graph. Okay, you'll have a hole in the graph if you'll get those factors to cancel, but this textbook does not go into that feature, so we won't either, and you won't have any examples that do that. Okay, so our first step is to find a vertical asymptote, and we have one, which is where? X equaling -1, where it makes that denominator equal 0. There it is, x equaling -1. It's a dashed line, a vertical line. Then we want to say, do we have a horizontal asymptote or do we have an oblique asymptote? Based on the degree of the numerator and the degree of the denominator, the degree of the numerator is 1, and so is the degree of the denominator. They're both a first degree polynomial. So when they equal, you have a horizontal asymptote at y equaling the ratio of the leading coefficients, which would be 4/1, or just y equaling 4. Way up here. There's your horizontal asymptote. Okay, so there's your two asymptotes. Then we want to find our x-intercepts. These are actual points on this line occurring when the y value is 0. So I tend to take my function out of function notation to do this because I think it makes it a little easier. And replace the y value with 0. And pretty consistently, this step is the step where we will cross multiply. And nicely, this works for us because we get something multiplied times 0, which is 0, and then 1 times 4x minus 2 is 4x minus 2. So then when we add 2 and divide by 4, we get 1/2 being our x-intercept. So at 1/2, 0, we have the location where we cross the x-axis. Well, I didn't give myself a lot of room on this one. Okay, then we're going to talk about the y-intercept, which is the point where the x value is 0. So this would be y equaling, it's 4x minus 2, so it would be 4 times 0 minus 2 over 0 plus 1. So it's a -2/1 or -2. So my y-intercept is occurring at the point 0, -2. You can probably get an image in your mind on this one, what this graph is going to look like without a calculator, but it's always reassuring to pick up that graphing calculator to determine it. Okay, and then our last step is always to say, okay, is my function going to cross my horizontal asymptote? Does it? And if it does, where? So this is where you set them equal. You set your function equal to your horizontal asymptote, which is my 4x minus 2 over my x plus 1, equaling my horizontal asymptote of 4. So I put my 4 over 1, and I cross multiply, and because of lack of space, I'm going to actually go 4x plus 4, equaling 4x minus 2. Okay, I'm going to cross multiply. I'm kind of skipping a step there in my cross multiplication. Then when you come in here and you subtract 4x off of each side in your algebra, you're going to get a statement which is not true. So the minute you get a statement like this where you have lost the x variable and this is a false statement, then your answer is no, they do not cross. Okay, so again, when the algebra kind of falls out like that, then you know that there is not a place where they cross. Okay, and so when you now turn around and graph this thing on your calculator, you could come up with a bunch of other points, but the easiest thing with our technology now is to graph it on the calculator, and it's going to look like this, never crossing any asymptote, but going through these 2 points which we found algebraically. Okay, there's what your graph should look like. Four steps we're pretty much consistently doing, actually 5. Vertical asymptotes, horizontal or oblique, X-intercept, Y-intercept, does your function cross the asymptote or not? 5 consistent steps, a lot of cross multiplying in here. Okay, one more example that we're going to work on today. So this one, I don't know if that numerator factors or not. I could take a 2 out of it for sure. And it does, doesn't it? And then this would be 2 times x minus 2 times x minus 2 over x minus 3. Now, really, the reason I so consistently do that is because if I were to get a couple of those binomials to cancel, that would indicate a hole in the graph. But again, this textbook is not referring to that, so they're not going to give me an example like that. But it is now factored. Okay, so where is your vertical asymptote? X equaling 3. Right here. Okay, then we have to discuss whether we have a horizontal asymptote or an oblique asymptote. Take a look at the degree of the numerator and the degree of the denominator. You have a degree of 2 and a degree of 1. Okay, when the numerator is more than the denominator, this means it is oblique. This means we divide. So really, the book is going to show you a long division like this, but we kind of get to sneak around and do something a little bit easier because the degree of the numerator, the degree of the denominator is a first degree, x to the first power. We can use synthetic division. So let's do synthetic division because it's much faster and much easier. 2, negative 8, 8, and bring down the 2. 3 times 2 is 6, we add. 3 times negative 2 is negative 6, we add. We're not trying to factor anything, so we don't care if that remainder is 0. And it does so little to alter my oblique asymptote that I can eliminate it. So my oblique asymptote is y equaling 2x minus 2. Now this is a straight line. This is a linear graph. And so we need a couple of points to graph it. And so I'm going to draw a table here and just come up with a couple of easy points. If x is 0, y would be negative 2. And if x was 2, y would be 2 times 2 is 4 minus 2. So this is my oblique asymptote passing through the point 0, negative 2, and the point 2, 2. So this is going to look, let's see if I can graph it free-handed here, something like this. And I'm not getting it very straight, but I'm trying. Okay, there it is. Okay, there's my 2 asymptotes. Looks like a big old X. All right. So that's a special case where you get to actually have an equation of an oblique asymptote using our skills of synthetic division. Okay, so now we want to find out, do I have any x-intercepts? Those are the values where the y is 0. So I go back to my original function, 2x squared minus 8x plus 8 over x minus 3. And I replace the y value with 0. Now, when I cross multiply, I get 0 equaling 2, x squared minus 8x plus 8. Okay, now this one, to solve this, it's a quadratic equation. You can go to the quadratic formula, x equaling negative b plus minus square root of b squared minus 4ac over 2a, but this will also factor. We factored it up here at the top into 2 times x minus 2 times x minus 2. So it does factor. We've already factored it. Okay, that's how it factors. So then I said each factor equal to 0. I'm going to come over here and do that. Well, 2 equaling 0 is not going to give us anything. And x minus 2 equaling 0 written twice is going to give me the same number of 2. So I have an x-intercept at 2, 0. Again, if your factoring is a little weak, remember you can go to the quadratic formula at this point. Okay, so at 2, 0 is right here. Well, I made a huge old dot for that one point. Okay, but there it is. So I came over here as I was trying to make room, because I know I need to make room over here to determine, does my function cross this oblique asymptote? So just as in every example we've done before, this means we set the function equal to that oblique asymptote. My function is 2x squared minus 8x plus 8 over x minus 3. And my oblique asymptote is y equaling 2x minus 2. So this one's a little more extensive when we do this algebra, but nothing we cannot handle. So I'm still going to cross multiply. So 1 times 2x squared minus 8x plus 8 equals x minus 3 times 2x minus 2. Now I'm going to have to do FOIL on the right side and simplify it. It's going to be 2x squared. Outside is a negative 2x. Inside is a negative 6x. Is that right? They were both, yeah, they're both going to be subtraction. Okay, outside is negative 2x and negative 6x is a negative 8x. And then a negative 3 times a negative 2 is a positive 6. Again, almost every time you do this, you're going to be able to subtract out the second degree polynomial, the second degree term. So I'm going to subtract off the 2x squareds. That's going to knock those out. And then if I also add the 8x's, that's going to knock those out. And so now I'm just going to end up with a statement which is false. Okay, so if it comes out to be numbers equaling each other which don't equal each other, then this is not happening. Does not cross it. Right, but that was a really good example to let you play around with that algebra and setting those equal to each other. Really good example. So now what we do is we go to our calculator, being sure that you put the numerator in parentheses and the denominator. Graph it and kind of follow along with what you have graphed so far, your guidelines, your asymptotes, and your points. Okay, and we forgot to do the y-intercept, didn't we? Did we? We sure did. But it looks something like this. The graph does like this and like this. And I forgot the y-intercept. How did I forget that? Probably because I just didn't have a whole lot of space, or I didn't think I had a lot of space. Okay, we're not going to have time to do this anyway. Okay, so I can do the y-intercept. The y-intercept occurs when the x value is 0, even though I've already graphed this thing. Okay, so this would be y equaling 2 times 0 squared, which is 0, minus 8 times 0, which is 0, plus 8, over 0 minus 3. So it's a negative 8/3. So we have a y-intercept at 0, negative 8/3, which is what, a negative 2 2/3? Right there. We're going to act like it's right there. My line went through it. Okay. My line went through it. Okay, so there it is. Just remember those 5 steps. Okay? Vertical asymptotes, horizontal or oblique, x-intercept, y-intercept, does my function cross or not? Then pick up your calculator, confirm it around your asymptotes, and you'll have that graph.